Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So today we are going to talk about optimal taxations. Before getting into much more in details about optimal taxations, we'll try to understand why are we talking about optimal taxation and why is it required for economy and also for the society as a whole. So why are we talking about optimal taxation? So first and foremost point is to have economic efficiency. Optimal taxation design is required to minimize market inefficiency and distortion. So that is the first point of discussion. So when we talk about optimal taxation, two things are important. One is of course the efficiency, and then we already discussed this in our previous lectures when we talk about tax incidence and tax burden. So the other point that we are trying to understand more and we really need to take into account for optimal taxation design, and that is for the redistribution purpose. So redistribution purpose, when we are referring, we are actually saying that higher tax on higher ability individuals. It is, again we discussed, like rich people should pay more taxes as compared to the poor people. And it actually helps to identify the problems, and tax on income or the consumption, that's how we debated. So these are the point on the discussion we already discussed in our previous couple of lectures, whether tax should be on the income or whether it should be on the consumptions. So now when we talk about optimal taxation, naturally the question comes like, why optimal taxation? So the government must raise revenue with minimum welfare loss. So this is like the main point of the discussions when we are talking about optimization of the taxation. Is like government must increase revenue, but at the same time it should not be at the cost of others. And therefore when we are saying that at the cost of others, it is basically the point that we are talking about is like minimum welfare loss. So now when we talk about optimal taxation, one really need to understand the household behaviors, because taxes or tax revenue collection happens from the household, and then household behavior actually change, or they change their behavior when taxation is imposed. Therefore, in a way we are talking about the trade-off between equity and efficiency. So when we are talking about optimization with regard to taxation, is basically we are talking about the trade-off between equity and efficiency. So to move further, let us also discuss about one of the discussion that we had before, but then let us again recollect that. It's like differential taxation. What does that mean? Taxes imposed at different rates on various commodities, they are actually known as differential taxes, and these are, again we discussed quite a lot in our previous lectures. So there are three taxes that we are talking about here. One is benefit taxes. So benefit taxes is like if we are using certain services and we are paying certain taxes for that particular use. So that taxes that we are referring as benefit taxes. One can imagine like airport lounges or say restaurant. If you are going there and then paying taxes, so that these are like only restaurants will get the taxes from the people who have used it, or passengers who are traveling by flight, they will actually pay the taxes to the airport, and that will go to the airport authority. So one can actually say that these are the examples of the benefit taxes. So now the second taxes that we are talking about, it is on corrective taxes, and then we discussed quite a lot in this particular context, and if you recollect, we also have spoken about Pigouvian tax, especially in context of negative production externalities, and there we introduced and discussed about the corrective taxes, and examples that we had given, like taxes imposed on cigarettes, or taxes imposed on certain industries who are actually polluting either on the river or on the air. So in that particular context, we can actually say that these are the corrective taxes measures that are taken. The third point is on the luxury taxes. Certain commodities like perfumes or diamond or gold, so some luxury taxes are imposed. So these are basically the examples of three different types of taxes that we are kind of discussing within optimal taxation when we are talking about differential taxation. So now there are various measures, but one of the celebrated measures that we discussed in context of taxation, and especially in case of optimal taxation, and that is the Ramsey's taxes, and that we'll talk about in details, and how we measure and how we calculate and how we derive, that we'll discuss in this particular lecture. So what is the question that we are addressing under Ramsey's tax? So the main objective for tax optimizations or optimal taxation is to how to reduce or how to minimize social welfare loss while keeping taxes or while imposing taxes on various commodities. So if you recollect, in our previous lectures, we already discussed whether we should have higher taxes on certain commodities, or we should impose lower taxes but on various commodities. So which one will give us more optimum benefit from the societies and also from the economics point of view. So this is the major objective of the Ramsey's taxes. We'll discuss that. So let us see what are the assumptions and how we actually calculate. The government set taxes under Ramsey's taxation on the use of income in order to accomplish two results. And I think we already discussed this, that whether we should impose tax on income or whether we should impose tax on the consumptions. And taxation on income, it is well established fact that this gives optimum taxation. At the same time, this also helps to understand the people who are able to pay the taxes, like propensity to pay the taxes. And then the first point that we are discussing here is raising the total revenue, like tax revenue. The second is the point that imposition of the taxes on income gives is like minimize the total loss for agents in the economy. Like here, agent is like individuals. So this is the first 2 points that we are trying to look for from the optimal taxation. The second set, the point that we are trying to discuss here is like we have to remember that key assumptions of the optimal taxation. One is no lump sum tax. So it is not like tax will be imposed and everybody will be imposed the taxes based on the total government spending, that we already discussed, and we are quite kind of agreed upon that that is not a optimal taxation situation. Therefore, no lump sum tax. Cannot tax all the commodities, like certain commodities should be exempted, but at the same time we also should not impose heavy taxes on very specific commodities. So this is also we really need to understand, and these are actually assumptions for Ramsey taxes. The third point is the point that production prices are fixed or the normalized, that we have to keep it in our mind. So optimal tax on the commodity is inversely related to its compensated elasticity. and that is what Ramsey's rule. So in short, in brief, how we actually derive or how we actually denote the discussion that we are having it, like T, if T is tax and I is say individuals, then Ti is inversely related to the elasticity of the commodity paid by the individuals. So what does that mean? That means tax inelastic goods to minimize economic inefficiency, right? So this is very important. That we also discussed that on which kind of commodities that we need to pay more taxes, whether it is on the elastic goods or whether it is inelastic goods. So we discussed that, but then we will try to bring that point and then we will try to understand here, especially in context of Ramsey's taxes. So now let us move further and then let us derive of Ramsey taxes. So let us formulate first what we mean. So from the definition, let us see what are we actually discussing here. So here we know the losses like social welfare losses. We also know how to calculate, and we have calculated through the dead weight loss. So here say dead weight loss for individual 1, then dead weight loss for individual 2, then we are summing it up like dead weight loss for individual 3, likewise dead weight loss for n. So where ni equals to 1 to n, so nth number of populations are there who are actually paying the taxes. So this is what we are trying to understand. So here we can say that total dead weight loss which are depending on the individuals, and this can be written as this, and this is what our total overall DWLI is the total dead weight loss for the society which are coming from n number of populations. So this is subject to what we can write as subject to our total revenue target, and total revenue target, let us assume that R, capital R bar, which is like fixed, and then total revenue like R1 is coming from first individual, R2 is coming from second individual, and then R3 is coming from third individual. Likewise Rn is coming from nth population. Therefore this is R1, so R bar is equals to tax revenue target. So if we look at the definition of the Ramsey's tax, is basically we have to minimize dead weight loss, total dead weight loss in the society subject to what is the total tax target that we are having it, especially what government actually having it. So that is the first the formulation of the Ramsey's taxes. So now this we can understand from Lagrangian's multipliers point of view. We already know, and therefore I'll be using that. And as we said that basic principles of economics, both micro and macro, are prerequisite for this particular course, and I'm sure you know that, especially the Lagrangian multiplier, how we use that in case of utility maximizations or in case of profit maximization in case of suppliers or for the production while taking production functions, and when we try to understand optimization of the utility, and we know how to derive from the utility function subject to the budget, and then in case of production function we try to maximize the profit subject to the total cost. So same Lagrangian multiplier we can actually use this here, and then we try to understand how it actually help us to come or to derive the Ramsey taxes. So now the third proposition that we are planning to make it. So first proposition is this, that our greater objective or the greater goal is to minimize the overall deadweight loss, certainly subject to total tax revenue. The third point is like to introduce the taxes. So here when we are talking about n number of populations are involved, and capital R1 is the total tax revenue coming from the first individuals, and R2 like total tax revenue is being collected from the second individuals. So the other point that when we are talking about taxes, so small t1 is the tax rate for the first individual, then tax t2, small t2 is the tax rate for the second individual, and then tax 3 likewise tn is the tax rate for the nth populations. So why we are calculating t1, t2, t3 and tn? Because of the differential taxes, and therefore we would like to understand how they are actually responding to the overall tax revenue target and also overall deadweight losses context. So here when we are trying to understand optimization discussion from the Ramsey taxes. So let us formulate now Lagrangian multiplier and set the problem. So using Lagrangian multiplier, we can formulate the problem as follows. So let us see that how we do. So we can say that deadweight loss plus like total deadweight loss. So we are actually making it for the n number of populations minus lambda. Lambda is Lagrangian multiplier, and then here we are writing is R1 plus R2, and as a student of economics we already know that this is how we frame or formulate Lagrangian multiplier. So what is the objective here? We are trying to understand how the overall deadweight loss or overall social welfare, how it will change with respect to changes in the tax rate for each individuals. So now if we try to do that, like delta, say we can write as I, and here with respect to T1 minus lambda delta capital R1 by T1, and as we know that first order condition will be equals to 0. So here I can represent as 1 because it's for the first individuals. So we can write as delta D W1 by delta small t1 minus delta minus lambda delta R1 and delta T1 equals to 0. So one can say this, that change in the total deadweight loss due to 1 unit change in the tax rate is nothing. We are trying to understand marginal deadweight loss for one individual equals to lambda marginal tax revenue. So that's why we can actually represent as delta MR1. So MR1 is marginal changes in the tax revenue. Therefore, one can write this as M MDW1 WL1 divided by MR1 equals to lambda, and likewise we can get MTWL2 by MR2, which is again equals to lambda. Likewise we can also calculate MDWLN divided by MRN equals to lambda. So this lambda is equals to the ratio between marginal deadweight loss for that particular individuals and marginal revenue or marginal tax revenue, that is what the value of the lambda. So and we can say this as, we can express as MDWLI divided by MRI equals to lambda, where I equals to 1 to n. So this is how we can actually first we can derive, this is the formulations of the Ramsey tax, and then deadweight loss and then marginal tax revenue. These two actually have included the taxes. So this is the first step, and we can give this as equation say 1, and then we will discuss more in details because the value of deadweight loss and value of marginal revenue will be different. Let us move further because we have to establish couple of functional relationship, because Ramsey's taxes talks about taxes, but then also its relation to the elasticity, like how taxes is related to the elasticity, and as we already know that it's an inverse relationship, but let us try to understand from the derivations, like how they are related. So now what we already know, that elasticity, say elasticity for demand, we already know it is actually the changes of the quantity due to 1% changes of the prices, and that is how elasticity of demand that we know. And then we also know that what is elasticity supply, so there also like similar kind of explanation, but this is in case of producers. So now suppose taxes is imposed on commodity which is directly going to the customer, like that means it will be impacted on the demand, and therefore it will be imposed on the prices, changes in the price on the demand curve, and therefore it will directly get connected with the elasticity of demand. It can also, we can also do this exercise with the imposition of the taxes on the supply. So let us first take the first example. It's like, let us assume that taxes is imposed on the consumer through its demand curve, and therefore we can see, like say price elasticity of demand will look like this, where tax is imposed on the price. So this is how we write, but we can also write as and I hope you agree with this expression, and then we can write as delta P plus T by P. So this is one expression that we know from price elasticity of demand, and let us assume this is equation 2, because in equation 1 we already know the ratio that we presented between marginal deadweight loss and marginal tax revenue, which is equals to lambda. So now from elasticity of supply that we know, so here we can also write delta Q by Q is like ES by multiplied by delta P by P. So let us give us the equation 3. So now from equation 2 and 3 we get ED multiplied by delta P plus T divided by P, which is equals to ES, price elasticity of supply, delta P by P. So now one can write this way, like this P and P will get cancelled out, and then ED delta P plus T equals to ES delta P. Here we can write as ED delta P plus ED T equals to ES delta P. We can write as, if we can take delta P, we can rearrange as ES minus ED equals to ED and T. Finally, we can write delta P is equals to ED divided by ES minus ED and T. So we can give this as equation 4. So this equation 4 actually shows the relationship between the changes in the price and then taxes, and of course the elasticity for both, like elasticity for demand and elasticity for supply. So now here we know that if elasticity's value, like if it is perfectly elastic or if it is perfectly inelastic, we know from the value of the elasticity, and then accordingly equation 4 will be changed, and this is what the first relationship that we are trying to establish, and then we'll see, like, you know, as we progress, like how it is getting connected with the Ramsey's taxes. So now let us move further, and then let's see how deadweight loss calculation or expression that we had put it. Like, what do we know from deadweight loss? Like, deadweight loss is nothing, it's the half of that we already know, and then T. So we know this particular expression, if you recollect. So deadweight loss, when we are saying, here is price, here is quantity, so this is the area that we are trying to understand. So this change is the change in price, which is nothing, which is tax, and here this is the change in quantity that we are trying to get it. So this particular area that we are measuring is like half of delta Q and T, which is delta P, right? So now when we try to get the value of the deadweight loss, so now the value for delta Q that we need, and that is what we are trying to calculate. So now already we know that the relationship between the price, changes in the price, and then tax. So now let us calculate price elasticity of supply, so which is like this, the formula, and then we get it we can get delta Q value, and delta Q is Q delta P, and then is a Q by P here. So now we know the value of delta P from our equation 4, and where delta P is, we can put the value of delta P, which is ED by ES minus ED T, and this is that we are getting it from equation 4. Okay, so now if we rewrite the entire, rearrange, like delta Q is basically ED ES divided by ES minus ED, then multiply by T, then multiply by Q by P. So we can give this as equation, say 6. So now putting the value of 6 into 5, and we get DWL is equals to 1 by 2, the value of delta Q that we have, ED, ES and ES minus ED, Q by P, T from here, and then we already have, that means T square. So this is what our overall, the value of the deadweight loss. So this is what our deadweight loss. So now if we calculate marginal deadweight loss with respect to tax, then we get delta DWL by delta, and we can write as marginal deadweight loss equals to 1 by 2, then 2 ED ES by ES minus ED, then Q by P, and then T, because this is first order condition, first order condition, and then first order derivative. It shows like with respect to T, so we get this, and then finally we get ED ES divided by ED minus ES multiplied by Q by P, like quantity and price ratio, and then tax. So this is what we get, marginal deadweight loss. So this is the marginal, the value for the marginal deadweight loss. So now we can give this as equation 8, and now we can actually also try to find out what is the total revenue. So tax revenue, so total tax revenue, it could be, we can write as capital R equals to tax rate, like T, small t is a tax rate based on the per unit, or one can actually refer as total tax target, revenue target. So here delta R, like again we want to understand the marginal revenue, tax revenue, like marginal tax revenue will be equals to T is nothing, is basically equals to Q, like total quantity. So now we can give this as a equation 9. So from the first equation, so from equation 1 we can write as like where marginal deadweight loss, marginal revenue is equals to lambda, this ratio. So we already know the value of marginal deadweight loss from equation 8, which is ED ES by ED minus ES multiply by Q P T multiply by 1 by Q, because that is the value of marginal revenue, equals to lambda. So now we can write this as like T by P multiply by ED ES divided by ED ES equals to lambda. So this entire value we can put like this is of course the elasticity. So elasticity of demand and elasticity of supply, these two are the value that we will get it from the types of the commodities and types of the demand, or the imposition of the tax on the commodities and how demand behavior, or imposition of the tax on the producers. It will also define like how supply behaviors, and that's how the elasticity of supply or elasticity of demand will respond to the changes in the price and quantity. So that we can actually write as a generic form like elasticity. Then we get delta P. So we can write as E and P. So this is how we reached, and we can give this as equation 10, and this is how we reach the relationship between tax and tax rate and the price level, and also the elasticity of the commodities, and lambda is constant. And here when we are talking about elasticity, here I'm assuming like elasticity of demand, and that's how we are trying to discuss here. We stop here.